Okay, here's my second attempt. I couldn't leave it at this one since it didn't meet 100% of my original goals in the design. Those of you who watched the video on the Screaming Photon Target Robot know that I had to leave the walking mechanism on all the time and use the spring slip clutch just for the upper part. My original design idea was that when you hit the target, which is the center hole here with the light, it should stop walking. The upper part should shake back and forth, the arm should move, the eye should change color, and it should scream. Did everything except for the stop walking. I was having a problem. With the slip clutch, which is this flexible urethane spring like you put around your wrist to hold your keys when you go swimming or boating. And because my original design, I had a shaft coming from the gear motor that went into half of the spring and then a shaft that went down to the walking mechanism. That meant I was actually only using about that much of a piece of a spring. That was divided in two, so there was very little area for either one to completely grab. See, one way when you turn this, it's going to cause the spring to open so it turns completely freely. You try to twist it the other way, it grabs because it's closing in on itself, and that makes your spring clutch. So what I finally figured out after I'd buttoned that one all up and was thinking, well, I guess I've kind of failed in getting both modes, and I went, no, let's try one more thing. And so I went back to the real patent route on this, which was the 1957 Z-Man. Shows that one side of the spring is connected, in their case, to a drive wheel in the front, and the other half just goes to the shaft. That way the shaft can use 100% of the spring to slip and grab, rather than two shafts splitting that same amount of area. So I took this and made a new coupler to the gear motor where the end of the spring is physically connected to that coupler, and then extended the length of the shaft of the walking mechanism so that 100% of the walking shaft could use the spring. Plus I continued the walking shaft up inside the coupler, so there was no chance that there would be a gap where this soft spring could start tightening in and close in, collapse on itself. It worked. That's all I had to do. While I was doing that, I decided I'd update a few other things that I wanted. I changed the ratchets in the feet to ones that produce a better ratcheting sound but have less friction. I added we'll call it a cam lock to the part that twists to make this move, so that when that shuts off, that can coast around till it locks on a cam lock, so it should almost always stop in the center rather than stopping twisted to the side one way or the other. Anyway, those were the ideas. And then I also went ahead and 3D printed a snap-on back battery cover. In fact, I did it for both robots. And by the way, this robot now needs to find a home. So if someone wants to pay about $100 for the robot plus whatever shipping to your location is, then that one can find a home. So here's what we ended up with. Very good walker, nice clicking sound. And then when you hit the target with the light, and then I'm going to run it out of table here, and then when you take the light away, you can switch back to walking. And the body centered out. So I got everything that I originally was hoping to have gotten on the first one. And here's a little slideshow of the new parts in case some of you that are interested in that sort of thing. So here's the new foot designs. Rather than completely designing the feet new from scratch, I basically took this foot design and just took the STL file and cut off the whole bottom part of the foot. Then I grabbed a foot from, say, the Laughing Robot that I just recently did, and I just merged the two files together. That way I could go with the larger rollers, so it rolls over things easier. It also gives me a better cam ratchets that are very low friction. And that was what I did with the legs. And here I am assembling them. Here's this one here, and they go into the base, and then these caps go over to capture them. And now you can see both of the cams that I was talking about. This one here, I'm going to zoom you in a little bit. So here is the motor is right here. We're looking at the end of it. This upper one connects to the motor, and here you can see it's physically captured the end of that spring. And I continued the drive shaft that was in here instead of stopping halfway like it used to. It now goes all the way, in fact, up inside here. Spins free inside there, but it goes all the way up. That way 100% of that spring can be used as a clutch. Like I say, when the motor turns in one direction, it's very low friction, puts no drive down to the feet. When it turns in the other direction, it tightens in on itself and grabs. Same thing is happening up here on the one that moves the body. You can see it better. Bring the spring through to this motor coupling. Put a cable tie around the end of the spring to the coupling so it can't pull out or move. The cam up here that makes the body shake goes all the way through the spring and into the coupling. So, worked out quite a bit better. Here's the front view of the electronics. Basically, I talked about it in my other build videos, but there's an H-bridge. It's actually a dual H-bridge motor driver for reversing the direction of the motor. And this is the photo optical sensor. Well, the sensor's right here, but the whole board is here and the sensitivity control is there. So basically, when this sees light, it puts out a low, drives a low signal into this board, which reverses the direction of the motor. This is the back side where the battery holder is going to be glued in place. And now the back, we're looking from the front, but the back side is in place. The switch has been put in. The battery holder is hiding back there. I have this set of wires just taped up out of the way for the picture. But basically what I'm taking is the two motor wires as a yellow and a red, and then the brown is just going to ground. And what that allows me to do is to use a common ground up there for the LED lights and a common ground for the sound chip. And then these other two are going to be positive or negative depending on whether you're walking or body shaking. So I can use those to change the colors of the LEDs. I used a red-green LED with a common cathode, which means a common negative. Here's the back. Here's the cam lock that I added to the very top, where the head would glue on top here, so we're looking at the very top of the body shaker. So now you can see how this can turn this way and it'll click. In fact, when the body was shaking, you heard the click, 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 click. But when the motor reverses back the other way, if there was any, if it wanted to back turn at all, it's going to back turn and stop at this point, which sets the body in the center, and then just holds it there. And I don't believe there's any other pictures there. Everything else was just the robot itself, which in the end I'm extremely happy with how it turned out. One more quick demo and then call it a day. You can hear the clicking. Like I say, there's a greeting card chip in there where I captured a scream, which I just grabbed off of YouTube. I typed in cartoon screams. I think that ended up maybe being a Tom and Jerry scream. Originally I was thinking maybe a Daffy Duck scream, like when he gets hurt, he has one that you always hear. But if you just type in cartoon screams, you'll come up with a whole bunch you can pick from to load into your greeting card chip.